Hello everyone and welcome back. I'm Samidha Varvekar from the Thetechunique. Today we'll understand what is meant by computer architecture and different key concepts regarding the same. In this topic, we will see what is computer architecture, its importance in terms of digital forensics, different hardware components and their functions, operating system concepts, and understanding the data storage and retrieval process and different key concepts regarding it. So let's see how these elements together form the structure and function of a computer system and how it helps in forensic analysis. So let's start with computer architecture. It defines the structure and function of a computer system, including its components, relationships, and organization. So basically, computer architecture is like a blueprint for computer system, which defines its structure, function, and organization. It ensures smooth operation and efficient data processing. In terms of smooth operation, it defines how the hardware components works together to carry out different tasks, like executing of instructions and processing of data. So it defines all the components work in a sync to carry out different tasks and efficient data processing. Means, for example, when we open multiple tabs in a browser, so computer architecture defines the processing time required for the each tab so that we can switch between the tabs quickly and easily. It sheds lights on data processing, storage, and access, forming the foundation for forensic analysis. Means it provides a kind of understanding on how the data is handled at each stage. Means how the data is processed by CPU, how it is stored into the memory, and how it is accessed whenever it is required. Next point is importance of computer architecture in terms of digital forensics. Computer architecture is important for digital forensics as it helps to analyze the digital evidence, identify the source of digital evidence. By understanding and analyzing the timestamps and logs, we can see from where the specific actions have occurred. That is, we can identify the source of the digital evidence. Analyzing volatile memory and system activity reveals what programs were running and what activity the user was performing. Data remnants. Data remnants means whenever the user deletes any sensitive information, some remnants or residues of that data remains on the hard drive. So from that we can reconstruct the event and it will help in the investigation process. Interpreting timestamp and system logs. So from timestamp and system logs, we can reconstruct the events in the series which they were happened at the time of the incidents or the crime. And as we know, different systems have different architecture, that is different hardware and software configurations. So by knowing the blueprint or computer architecture, it helps us for choosing the best investigation tool. Now let's take a closer look at hardware components that togetherly make up computer architecture. So in that we'll see CPU, that is central processing unit. So as we all know, CPU is the brain of the computer. It basically executes the given instructions and perform operations like arithmetic and logical. Modern computers have multiple cores which allows them to handle more tasks simultaneously. Now we'll see the components of CPU, that is control unit, arithmetic logical unit, and registers. Control unit. Control unit controls the flow of the data and instructions within the CPU and ensures that it's in a proper sequence. Arithmetic and logical unit, it performs arithmetic and logical operations which are required. And registers. Registers are like short-term memory of the CPU. They store short pieces of data which CPU requires for performing immediate tasks. Next important point in terms of CPU is the function cycle, that is fetch, decode, and execute cycle. So in the first step, the CPU fetch the instructions or gets the instructions from the main memory, that is RAM, random access memory. In the next step, once the instructions are fetched, it decodes those instructions to understand basically what task is need to be done. Now the CPU performs actual operation. It may be arithmetic or logical, that is execution step. And in the last step, the results of the execution are stored back into the main memory. So in this way, CPU works, that is fetch, decode and execute cycle. So the next component, hardware component, is storage devices. Basically, storage devices are used to store data. They are divided based on the purpose of their usage and different technology. So they are mainly divided into two types, that is primary storage and secondary storage.
So these are the different types of storage devices shown here in the image. That is internal hard disk, CD or DVD, external hard disk, memory card, smart card, USB flash drive, and others.
So the first type in storage devices is primary storage. Primary storage is mainly RAM, that is random access memory. Primary storage is used to store the data which is currently in use by the CPU. It is volatile in nature, means the data is stored temporarily and it is lost when the power is turned off. These primary storage is faster as compared to secondary storage and it can be quickly accessed by CPU. Next type is secondary storage. These are the long-term storage devices. It is used to store the data which is not currently in use by the CPU. It is non-volatile in nature, means it holds the data even when the power is off. These devices provide larger storage capacity but slower speed as compared to primary storage. Examples include HDD, hard disk drives, SSD, solid state drives, optical disk, and USB drives.
These are different types of secondary storage devices like HDD, hard disk drive, DVD, compact disc, CD, pen drive, floppy disk, and memory card.
In storage devices, further we'll understand how the data is organized and retrieved. Sectors, tracks, and clusters are the organizational components of storage devices. Sector is the smallest unit of a disk. It is of fixed size. Basically, the sectors are the building blocks for storing and retrieving data, and each sector holds a fixed amount of information. So, for example, imagine a book. So, each page of a book represents a sector, and each page is of fixed size, that is of fixed unit. Next is track. Track is a concentric ring on the disk. Concentric means circular ring on the disk where the data is stored. It is like a circular path on the surface of the disk. It provides a way to organize the data. Each track consists of a sector which forms a complete circle on the disk. So for example, imagine a book as a whole. So the whole book is a track and each page is a part of that track. So track arranges the content in a systematic way, just like the circles arrange the data on the disk. Next is cluster. Cluster means group of sector and it is the smallest unit for data allocation or for arranging the data. So when the file is saved, it occupies the entire cluster. So for example, consider a shelf. It contains several books, that is cluster. So when we organize the shelf, we assign or allocate the space on the shelf for each book, that is cluster. So this is diagrammatic representation of sectors and clusters. So as we can see, the tracks are cylindrical or circular in shape. We'll see it in next diagram. So in this image, track, sector and cluster are shown on the hard disk. It is a structure of a hard disk. So the tracks are given in red color, that is point A, which is a concentric ring on the hard disk, on the surface of the hard disk. Point B, it is the sector, which is given in blue color. And C, as we know that track each track, it consists of a sector. So C point is the sector of a track and the green point is the cluster. Next point in storage devices, data remnants. Data remnants refers to the residual representation of data that persists even after attempts to delete or overwrite it. It means even if the user deletes the data, traces of information remains on the storage devices. Forensic analysts leverage data remnants for data recovery purposes. Techniques such as file carving may extract remnants of deleted files. So this is important in forensics as it helps the analyst to extract the remnants or residues of the deleted files to reconstruct the digital evidence. So for this purpose, techniques like file carving are used to extract the remains of those deleted files or to extract the fragments of deleted files. So for example, if you may delete some sensitive document while you no longer see the document on the storage device, but still its fragments or some remains are residing on the storage device. So the analyst can uncover those and reconstruct them and use for the investigation purpose. Next component is input-output devices. Input-output devices allow the users to interact with the computer and transfer the data to and from the system. So as we all know, input devices allow the user to interact with the computer by providing the data or input, while output devices produce the results of the processed data. Different input and output devices include projector, printer, speaker, keyboard, mouse, scanner, monitor. Role of input-output devices in digital forensics. Input-output devices plays important roles in gathering and presenting the digital evidence. Analysis of timestamp. It provides timeline of events like timestamps on files, logs from input device and output device can be analyzed to reconstruct the sequence of action. For example, timestamps on keyboard logs can be analyzed to determine when specific entries were made. Extraction of data. Input device record user interactions while output devices store results. So the analyst can extract the data from these devices for investigation. For example, extracting the data from the printer's memory. Identifying evidence. Often input devices and output devices contain the traces of digital evidence like printed documents, keystrokes, or images captured. These are some traces of the evidence or evidences. So analyzing these helps in reconstruction of events and understanding the user's action. So in this way, input and output devices play an important role in digital forensics. Next important point in computer architecture is operating system and different concepts regarding it. Operating system bridges the hardware and software, orchestrating resources for efficient program execution. Operating system is basically a bridge between the computer hardware and software applications. It manages the resources and allows the application to run efficiently. The goal of operating system is to execute the user programs and make the task easier. For example, in case of a printer connected to a computer, operating system makes the communication easier between the word application software and the printer, that is the hardware. So, objective of the operating system is to make the tasks easier. It is a software that manages and controls the entire set of resources and effectively utilizes every part of computer. It ensures systematic usage of the resources like CPU, memory, storage, and input-output devices. Means it utilizes every part of computer. Functions of operating system. In that, first we'll see resource management. Operating system manages hardware resources to ensure the proper system performance. It includes CPU, memory, storage, and other devices. In case of CPU, if the multiple applications are running, then operating system allocates CPU time to each application. In terms of memory, operating system allocates the portion of available memory to each running application. In terms of storage, operating system manages the file system, organizes data and provides access whenever it is required. And also it manages the peripheral devices, makes the communication easier between the hardware and software application. Next function of operating system is process management. Process management means looking after the execution of multiple processes. Operating system handles process creation, scheduling, and communication. Operating system schedules the process based on the priority and also terminates when they are no longer required. Memory management involves allocating and deallocating memory space to different processes. Operating system ensures proper use of memory between the different processes. Virtual memory. Virtual memory is a technique which extends the computer's physical memory by using the portion on storage device, that is on hard disk and SSD, for execution of the process which requires more memory. Paging. Paging involves dividing the physical memory into the blocks of fixed size, which is called as pages. So for example, if a program needs more memory, then paging allows the operating system to move less use of portion of a program, that is pages, to storage device and free up the physical memory for execution of other program. In memory allocation, the portions of memory is assigned to different programs. And in terms of deallocation, it means releasing the memory which is no longer in use. Means whenever we close a program, operating system deallocates the used memory. Next is file management. File management includes organizing, storing, and retrieving the data on the storage device, managing file system, directories, and file access, that is access control. So for example, whenever a user saves a document, operating system determines where the file will be stored. It manages the permissions, file permissions, so that only the authorized users can access or modify those specific files. Next point in computer architecture is data storage and retrieval process. Data storage and retrieval process in operating system involves allocating the storage space, optimizing data access through caching and buffering, and implementing of some data hiding techniques. Data allocation, it means assigning the storage space for the files and data on the storage devices. Operating system manages how and where the data is stored. Caching. Caching means storing the data which is accessed regularly in the memory for quick access. Buffering. Buffer, it means a temporary storage area in the memory where temporary data is stored. Further, we'll see data hiding techniques. Data hiding techniques, it involves methods to protect and hide the data for security and privacy purpose. The techniques are slack space, steganography, and encryption. Slack space, it means the unused space which is at the end of the storage unit, that is sector. It may contains the remains of deleted files. Steganography, it means hiding the data within other files like images or audio files. Encryption. Encryption means encoding the data to make it unreadable without using the decryption key. So far, we have learned about the computer architecture and in that hardware components and operating system concepts. So, understanding computer architecture is important for digital forensics. It depicts how the system operates and how the data is managed. All those concepts which we studied helps in reconstruction of events and for understanding user activities during the terms of investigation. So this was all about computer architecture. Thank you for watching.